Today we are doing sketching parabolas, exercise 7b. So I would like you to copy down the notes. Thank you. So they're all examples here, so make sure you leave big space. Or if you just want to leave it till I do it, you can do that. Alright, so I'm going to explain a little bit here. So this is very similar to last lesson. So, sketching a parabola. A sketch is not drawing it out accurately. To draw it out, you'd use a table of values, and you get lots of different coordinates, on a table of values, the x and the y values, and then you plot each of the points. That's called plotting or drawing a graph. A sketch does not have to be that accurate. So, the sketch, we draw the curve and we label the key features. Things we label are like turning points, TP, and x and y intercepts. But in these questions, they're only actually asking you for the turning point and the y-intercept. So read the question as to what it's asking for. Alright, the turning point form of an equation is like this. So you've got y equals a, the number out the front. So remember, that's the dilation factor. If it's greater than 1, it makes it skinnier. If it's less than 1, it makes it wider. X minus h. Now the h means it moves left or right. So if h is 5, then it moves, which way? If it's negative 5, it moves to the right, remember that? And k is how much it moves up, because it moves up or down. So it says there the turning point is hk. So there's the x value, and there's the y value. Anyway, we'll get to that in a minute. Alright, so it says sketch, labeling the turning point and the y-intercept, each of these graphs. We did these last lesson. So y equals 3x squared. I'm just going to do a little sketch here, label that x and y. Okay, so the 3 makes it skinnier. So if you remember that, so here's I'll do my normal one, y equals x squared if you like, I'll do that first. And then this one is skinnier. And make sure you label it y equals 3x squared. And that's what the graph looks like. Now the thing is, when you've only got 1 point, so we can label what the turning point is, 0, 0. So the turning point is 0, 0. But since we've only got the 1 point on the graph, it's often very handy to find another point. And often we find a really easy one, find out when x equals 1, what's the value there? So you say when x equals 1, substitute it into the equation. 1 squared is 1, 3 times 1 is 3. So we know the y value is 3. So that point there is 1, 3. So whenever you've only got 1 point on a graph, just substitute and find another point. So the easiest value is x equals 1. Excellent. And that's the first one done. Let's have a look at the next one. Y equals negative x squared plus 4. So if we do our little sketch again, there's our axes. What does a negative do? It moves it upside down, or reflects it, it's called, in the x-axis. And the plus 4 means it goes up 4. I like just doing that to remind me of which way it goes. So my turning point is there at 4, and it's an upside down parabola. So it looks something, just a normal one, so it looks something like that. Don't forget the arrows. So there's my parabola. So my turning point is 0, 4. And we need, it just says label the turning point and the y-intercept. So what we could do is just say when x equals 1, because you need to find at least one other point. When x equals 1, so we get 1 squared is 1, but it's negative 1. So you do the x squared bit first and a negative at the end. So does that make sense? So 1 squared is 1 and then it becomes a negative. So negative 1 plus 4 is 3. So y equals 3. And that makes sense because when that's 1, the y value there is 3. So we can put that point in as 1, 3. Excellent. Some people do this maths wrong. When they substitute 1 in, they say it's negative 1 squared, which would be positive 1 plus 4 is 5. But if you did get 1, 5, the point's up there. You know that's not a sensible answer. So use common sense. And just another point, it doesn't ask for it here, but we can actually find the x-intercepts by x-intercept let y equals 0, and then we use factorising skills from a previous topic two topics ago. But we won't do that right now. Next one. y equals x minus 2 all squared. The minus 2 moves it 2 to the right. So, let's draw our little graph again. Alright, so our turning point is there, and it's our normal parabola. And there it is. And what do we need to do? Oh, it says in the y-intercept. Y-intercept, let x equal 0. Do you remember that? Y-intercept, let x equal 0. So that's 0. So 0 minus 2 is just minus 2. Minus 2 squared is positive 4. So that point is 0, 4. And we can label it 0, 4. Excellent. Now next one. So a negative 3 moves it 3 to the right, and minus 2 at the end moves it 2 down. Alright, so and that's moving the turning point, position of the turning point. So it's still an upright graph, and because there's no number out the front, it's not wider or thinner. So it's moving, okay, whoops, doesn't matter which colour, let me just do that one now. Alright, so there's x and there's y, so it moves 3 across, so there's 3 and 2 down. So that value is negative 2, and there's my turning point. Alright, and it's a normal parabola, so it goes up like that, something like that. And I don't know exactly where it crosses, I don't know exactly what the values are, but we can write down, so the turning point is 3 minus 2. We work that out just from here, because that's actually called turning point form, that equation. And now we can find the y-intercept. Remember that? Let x equal 0. The y-intercept is always easy to find because you let x equal 0, and it's just negative 3 squared is 9, positive 9. Positive 9 minus 2, 9 minus 2 is 7. So you get y equals 7. So this point here is 0, 7. Obviously I haven't done it to scale, it should be up a bit like that, but remember it is just a sketch. So that point there is 0, 7. Good job. And the last one up here. So, let's have a look before we do anything. It's a negative, which means it's an upside down parabola. It's plus 1 in there, so it means it moves it 1 to the left. And it's plus 4, which means 4 up. So, let's do my axes here, x and y. Okay, so it moves 1 to the left, so there's negative 1, and 4 up. So there's 4. So there's my turning point, and it's negative. So it looks something like that. Put my arrows in. So my turning point is negative 1, 4. And my y-intercept, we can find this point here. What do? We let x equal 0. So y, you might have to do a little bit of work for this. So remember, it's got a negative out the front. So that's 0, so 1 squared is 1, but now it's a negative 1. Plus 4, negative 1 plus 4 is 3. So that is 0, 3. And is that a sensible answer? 0, 3? Yes it is. So remember, it's just not drawn to scale, so that's a sensible answer. If you've got something like 5 for this, say you got the negative wrong, and 0, 5, obviously it doesn't make sense because it's an upside down parabola. So always use common sense, and that's how we do it. So that's a sketch. We've found the turning point and the y-intercept just like it asked. In the future, you'll be finding the x-intercepts as well. And that's when you factorise and then use the null factor law. Alright, now the last one is a slightly different type of question. So this time we've got a graph sketch there, and it says find the rule of that equation. So if you remember right from the start of our notes, that's the generic formula of a parabola. So it's got y equals a, that's the dilation factor, y a little thinner, and then h, and then a k at the end, that's the x and the y value. So the first thing we can do is substitute the turning point in. So we substitute the turning point, which is here 0 and negative 1. And remember, the turning point is, this is the x value of the turning point, and that's the y value of the turning point. So if you write down our equation now, we get y equals a, x minus 0. X minus 0 is just x, so I don't need to worry about that, and then it's negative 1. Because k is the y value of the turning point, so negative 1. So I'll substitute that in, right there, that is the turning point. That's the turning point there that I've substituted in. So now I know it's of the form Oops, sorry, and there's a square there. I can't forget that. Alright, so now we know it's A is a dilation factor. We just need to work out, is this graph skinnier or wider? And we know that the turning point is moved 1 down. And we can see that because it's, the turning point there is 0, -1. Alrighty, so now we've got a simplified generic formula, but we still don't have the value of A. So what we need to do is substitute this given point, this known point in. So we're going to substitute the point 1, 2 into this equation. And that's an x value and that's a y value. So we substitute them in, we get 2 equals A times 1 squared minus 1. 1 squared is just 1. 2 equals A minus 1 plus 1 to both sides, and you get A equals 3. So our equation is y equals 3x squared minus 1. And that's the equation of this graph. You can check it's a little bit skinnier because of the 3 there, and you can see it's been moved down 1. So I'll quickly just go over how I got that again. So there's a generic formula for a parabola. I used a turning point value. I substituted the turning point because we know this is the x value of the turning point and that's the y value of the turning point. So we substitute those into the actual equation. Since that's 0, it's just x squared. So it's ax squared plus k, but k is -1. So we put in -1. So now we've got that equation there. We substitute in a known point. 1, 2 could be anything that they've given you, but it's 1, 2, substitute it in, you work it out, you get the value of A. So and there's our equation, we substitute that back into this, and there we have it. So I would like you to have a go of exercise 7b, try all the questions, but there's a lot of them, so go every second question is fine. Check your answers in the back, email me if you've got any problems, and I'll see you soon. Bye.